Hi guys, I recently came across an interesting project on GitHub that is called Self-Operation Computer Framework. In a nutshell, what it does, it actually allows a software to control computer inputs and read the outputs just as normal human would do. There is an AI model that actually views the screen and decides on a series of mouse and keyboard events to reach an objective that it's given in the form of a prompt, just like you would do to a chat GPT. And as you can see here in this video they provided, that their bot is fully capable of opening a browser, navigating to a Google Docs page and writing something in it. This is quite an interesting feature that I decided to explore further. As you know, with an introduction of ChatGPT and its API, there have been many tools that emerged allowing you to automate certain tasks. Many of them came in a sort of web browser extensions, like this Taxi AI, for instance. What this tool allows you to do is to perform a specific task on a page, like scheduling an event in Google Calendar or searching a movie on Netflix. This tool takes the entire DOM, cleans it up a bit, and then sends the result to large language model for processing. Then downsides here are obvious, as we are sending a lot of textual data that comes with a lot of noise, and often large language models are unable to do an accurate interpretation of all of it. However, with the multimodal models like GPT4-V, the solution appears to be considerably more feasible. The solution frequently involves capturing a screenshot of the desktop or a web page and drawing various bounding boxes to annotate the interactive path that the model should take. By providing these clear annotations, we can offer large language model guidance on which elements to interact with. This significantly enhancing the task completion for the GPT-4V as opposed to just sending the whole DOM to the large language models. The way it works is you begin by capturing a screenshot, then you create annotation and forwarding the annotated screenshot to a multimodal like GPT-4V. This model then provides instructions for subsequent steps. Following this, command libraries are employed to control either a computer or a browser. This process precisely outlines the functionality of this self-operating computer framework, and to observe its operation firsthand, you can explore this self-operating computer GitHub link that will be in a description. But let me just show you quickly how it works for me here. Once you clone the repo locally, you can go through the README file, which explains how to install all the necessary Python dependencies. All you have to do is just basically type in this command in a terminal, and it will install it. I already have everything installed, so all I need to do is just type in operate, and it will ask me for the API key for the OpenAI GPT4-V model. And this is what I'm going to end up using, but it can actually work with multiple different other models, some of them being Gemini Pro Vision, which is the Google model. There's also Claude 3 model and Java model. I don't know, I never used any of these other models, so I'm just gonna stick with the OpenAI GPT-4V. I got the API key for it. I'm just gonna type it in, click OK. It warns me about it being experimental framework, and I got hello, I can help you with anything. What would you like done? So let's do something simple and ask it to go to the internet and find out what's the weather like in Pittsburgh. And let's see what it does. At a minimum, it should open up the browser and search inside the browser. So that's exactly what it's doing. It's opening up Google Chrome. it opened up on a different window. So let me just move it here, because sometimes it gets confused. It only works with the current screen, and if it can't find it, it gets confused. So it opened up second time, now it opened here. As you can see down below, it actually tells you what the next step should be. It tells you what it write in a search bar, and then it tells that it needs to press enter to find the weather information. Now it tells you that objective is complete, found the current weather in Pittsburgh, which is sunny with the temperature of 52 degrees. As you were able to see, it actually just typed in weather in Pittsburgh and it went by default to Google. Sometimes it takes a different path. It goes to a weather.com and tries to search on that website. Sometimes it finds it there, sometimes not, but it tries different approaches every time when you run it. If we look at the code here, as you see here in the screenshots folder, this is the last screenshot that it actually sent to the GPT4-V model. And this is where it actually got all the weather information from. Now, if we take a look at some of the source code of this, you will see the prompts that are being generated by this software before it sends it to the GPT4-V. You operate in a computer using the same operating system as a human. From looking at the screen, the objective and your previous actions take the next best series of action. And you have 4 possible operation actions available to you, which are click, write, press, and done. Done means the objective is completed, it found the information that it needs, and was able to serve it back to the user. And these are some of the examples, how to do it, doing a search in a Google Chrome, how to focus on an address bar, and some other notes. And it works pretty good, but sometimes very inconsistent. And a lot of times it happens because GPT4-V wasn't able to accurately interpret the position of the mouse on a screen or the particular element, because the way it works, it actually it takes the screenshot and it basically divides it into quadrants like this, and shows the percentage points for each quadrant. And when this screen gets submitted into GPT-v4, it based on this percentage values, it tries to estimate the position of particular element on the screen. It then sends this back to the control software and is able to click onto that element and type in something there or press on a button. And this actually works good enough, but probably as good as you can make it, because after all, it's just a desktop computer. There's no good way to create bounding boxes on different elements on a screen. However, if we change the AI scope to just the browser, then the accuracy of getting the correct elements from the screen should be much higher. Because with the web page, we can easily use CSS to draw these bounding boxes around the elements, and we can actually use GPT-4-V annotations for them as well. And this is what I wanted to demonstrate today. There is a repo that was actually created. Here it is. It was created by the guys at Unconventional Codings. They made this GPT4 Vision API and Puppeteer power tool that can answer questions based on website screenshot. You ask it a question and it will browse to a website and takes a screenshot. Then it will use GPT4 Vision API to answer the question based on the screenshot. This is exactly what we need. So I forked and cloned that repo locally, and I will show you how it works in a second. But first, I wanted to give you an idea how the most basic vision model example works. I made this rudimentary Node.js application that goes onto a web page and then extracts the data we need from that page using vision. For that, we're using Playwright, test framework that just launches the browser and able to navigate pages. So a few components of the application is, one of them is this function image to base 64 conversion. So basically, once the Playwright makes a screenshot of our page, we need to convert it to base 64 that we can then submit to GPT4-V model. Everything's pretty simple here. We just launch a browser, we go to a new page, we set our viewport size. This is important because we want to make sure that the content that we need gets onto the page. Then we go to the page that we need and we make a screenshot. It's also capable of making full page screenshots for the pages that are pretty long, and I will show you that in a second. But for this example, all we need to do is just to make a simple screenshot of top of the page. So then once the screenshot is made, we convert it to base 64 and send it to the OpenAI model. In the content, we just specify the image URL, our base 64 image, and a prompt. The prompt in this case is given a web page showing a picture of the day. Describe in a single sentence what is displayed on the first large picture of the outdoors. What we'll be navigating to is this unsplash.com picture of the day. Let's start it up and see what it does. So it started the browser here and it went to this page. Now, because I have it in a debugger, it actually stopped here so we can verify that our image was actually created. This is the image that it took of this page. Now let's hit the continue button and see what it will output. It sends the image to the OpenAI model right now, and we should get the results back in a second. GPT came back with this, so let's compare it to our image. GPT says the first large picture displays a serene outdoor scene with a misty, sunlit landscape featuring a reflective river meandering through an autumn-colored valley. It is indeed looks like it. The second example I have for you here, instead of going and looking at the picture, it will take a look at this web page of the YouTube channel of Ilya Varlamov, which is one famous Russian blogger. So let's give it this link to the YouTube channel and ask it, given a web page showing a YouTube channel, explain in one sentence what this channel is about, who makes its content, and what language is it in. So I'm going to start it up, and it opens up the browser, goes to this channel.
I bought you some song. I don't know where you are, but I hope your money is just...
No, it automatically starts playing, and let's see what image it actually took as a screenshot here. We're now gonna hit continue here, and this will send this page to a GPT, and we should get a result in a second. So the GPT tells us this YouTube channel features content created by Ilya Varlamov, an independent Russian journalist who explores various locations around the world, and the content is primarily in English. It was able to extract all that information just from this one screenshot. And I'm pretty sure if I wouldn't limit it to just one sentence, it spitted out a lot more information, because in this case, I took a screenshot of the entire page as opposed to just taking a screenshot of a viewport. There's an option in Playwright to take a picture of the full page. So if your page is really long, like a Wikipedia article, you are able to take a screenshot of that whole entire page and send it to ChatGPT. There are many different use cases for this. For instance, I've seen a use case where you can send a LinkedIn profile of a person and ask it to extract all the information from it. Because LinkedIn profile pages structure can be quite complex, and if you take a look at the page, there's a lot of nesting here. It's very difficult to separate the information that you need. Using GPT-4 Vision is a much better way to extract the information that you need, because it will only see the information that you would normally see as a real human being. Now, let's go back to the original library that was written by the unconventional coding. All it is just another Node.js script with already familiar to us image to base 64. an input function that allows us to read the input from the user. And there's a method that's called highlight links. So once we took a screenshot, what we're trying to do is we're trying to find the elements of this type. So it's either the link, the button, the input, the text area. With these elements, we're trying to make sure that they are visible on a page in a viewport. And if they're not visible, we just return. But if they're visible, we then create a 1 pixel solid red bounding box. This will help GPT-4 Vision to identify what is an interactive element on the web page. Inside that element, we also set an attribute with the link text. Inside the main function here, we need to set up our browser, which is going to be running in headless mode normally, but for our intents of testing, we'll change it to false. We start a new page in the browser, we set a viewport to our widths and heights. Then we need to set up our OpenAI GPT model. First, you have to let the model know what its purpose is before you submit any data to it so it can more accurately process it. So here we're just telling it that it's a website crawler, given instructions on what to do by browsing. You are connected to a web browser and you will be given the screenshot of the website you're on. The links on a website will be highlighted in red in the screenshots. Always read what's in a screenshot. Don't guess link names. You can go to a specific URL by answering with the following JSON format URL, and the URL goes here. You can click on the links on a website by referencing the text inside the link button by answering in the following format. Once you're on the URL and you have found the answer to the user's question, you can answer with the regular message. In the beginning, go to the direct URL that you will think might contain the answer to the user's question. Prefer to go directly to the sub-URLs like google.com search. Prefer to use Google for simple queries. If the user provides a direct URL, go to that one. Now, once we give it a role, we can enter our prompt to the model. So it will wait for our input here. We'll push that input into the user messages, and then we just start a forever loop, which basically just stitches up the functionality that we already discussed above. Inside this loop, if we have a URL set, it will instruct the browser to go to that page. If we have the screenshot taken, it will try to send this screenshot to a GPT. If we don't have any of that, that means we are ready to send messages to a GPT vision model to get some instructions on what we need to do next. And this is basically what this code does. Then we get the response message back. Now, if the message from GPT contains the following, that means it wants us to click on a certain link. And like I was showing you before, when we were highlighting our links, we were giving them this attribute. And inside that attribute, textual content of that link or whatever object that is. So if GPT wants us to click on that object, which is basically collect the array of all these elements, and we'll try to see if that element contains that message that GPT sending to us. So if it will be calling button submit, it will be trying to find an element with that text inside it. Then if it finds that element, then it clicks on that element and it just waits for the page to load. Then it highlights the links on that page again and then makes another screenshot, and then it repeats. If something goes wrong with the clicking on the link, it just displays a message with an error. If we don't get instructions back from the GPT, we just display the message with an answer because we assume that is the answer to our objective. All right, so now let's see how it works. So we just start this process, immediately launches a browser instance, and inside the terminal, it tells us, how can I assist you today? So starting with something simple, we'll give it this. What's the weather like in Pittsburgh? And let's see what it does. It instantly goes to the Google search page, draws bounding boxes across all the page with all the interactive elements, but I don't think we'll even need to go anywhere from this page. It might be able to give us an answer right away, so let's wait. There we go. The weather in Pittsburgh is currently sunny with a temperature of 59 degrees. So it was able to give us the answer for that question from this page only. Now let's give it something more complex. And let's feed it with the following prompt, where I can buy the cheapest 2024 Honda Accord in Pittsburgh. Let's see what it will do. So it goes to the Google search page. Now it's clicking on 2024 Honda Accord for sale near me in Pittsburgh. It means to click on this link over here. Okay, and we got stopped in a debugger here. So I'm gonna just let it run through. Didn't find the exact match, but it found the partial match. So let's let it run through. So it went to the Auto Trader website, and now it drew the bounding boxes across all interactive elements, and now trying to decide where to go from here. Cheapest one listed is 2024 LX with the manufacturer MSRP 28,000. So this is the one that it found on a page. Given that it only sees what's on the current screenshot, it was able to identify whichever one is the cheapest on this particular page. Now, imagine that you are a dealer and you're working in a car business and you're trying to move inventory, and for some reason, customers not coming to you because you're probably not priced competitive. So what you can do, in theory, you can list out your competition websites and make this bot scout these websites on a day-to-day basis, just log into the inventory website and check their listings, compare them against your own, and make an educated decision about how you should price your vehicles. And someone who has this functionality will definitely have a competitive advantage over the other. Having a digital agent capable of executing complex tasks like this greatly simplifies many workplace integrations. And you no longer require to have a hard-coded API for certain tasks, as you are now able to program an agent with a simple commands. That's it for today. I hope you found it valuable. Stay curious. Bye.